Okay, so we got another, or the last topic actually, principle of similar figures. Okay, so for number one, we got given are the sides of a similar polygon, which are 12 and 21 centimeter respectively. Find the area of the largest polygon if the area of the small polygon is 64 square centimeter. So we have S1. Okay, that's the first side, which is 12, and then we got S2, which is 21. So this is in centimeter. And then it's said to be that the area of the small polygon, so area of the small polygon, so that will be the area of the 12 centimeter. So that would be A1 is 64 centimeters squared. Okay, so if you're dealing with similar figures, all you have to do is just something like this. So S1 over S2 is equal to A1 over A2. However, as you can see, if you consider the units, A1, the area are in square, right? That is square centimeter, square meter, square feet, anything like that. So this is already squared, but for the S1 or the sides, that is just centimeter. So in order for them to be equal, this should be squared. Okay. So in that case, now we can use now this equation. Okay. So let's substitute the values. You'll have here 12 over 21, right? Squared is equal to A1 is 64, and then A2 is the one that we are looking for. So this is simply A2 is equal to 64 using algebra, 21 over 12 squared. So the answer for this one is, I think I already have answer for that one. That is 196. 196 square centimeter. So this will be the answer. So let's do number 2. Okay, so for number 2, we have a conical tank with its vertex on top is filled by water up to 2/3 of its height. So it's a conical tank and the vertex is on top. Okay, so find the ratio of the volume of water to volume of tank. Okay, so it should look something like this. So we have a conical tank. Let's make a big one. So this is the triangle, right? And then okay, so it should look like this. Okay. Then let's just erase this one. Okay, so that is a cone with vertex on top. Okay, so this is the vertex. Okay, so let's put labels. Um, so we got a water here, right? So we got here some water. So this is the water line or the surface of the water. Okay, so let's say that this part. Okay, so this part is volume of water, VW, and let's just call this one V. Okay, and then of course the whole tank is VT, or the volume of the tank. So we are required to find what ratio of volume of water to volume of tank. So volume of water to volume of the tank. Okay. Okay. And the next, we can say that the volume of water or the height for this one is 2/3 of the height, right? Sabi, that is 2/3 of the height, and then of its height. So find the ratio. Okay. So if that is 2/3, of course, this full height is h. It's already a given, and then the remaining height will be h. So what we gonna do is we are required to find volume of water over volume of tank. So the ratio of those two. But as you can see, the volume of water, that is not a triangle, right? That's not a triangle, this one. This one. This is not a triangle. That's actually a trapezoid. So, but this one is a triangle, right? So we can use volume of, we can use similar triangles on that. But we cannot use similar triangles with using the VW. So what we will do is the volume of tank, right? Volume of tank, that will be equal to um, volume of the V part, okay, plus the volume of water. And then next, since we are looking for VW over VT, therefore we can say that what do I, um, volume of water will be equal to V of the tank minus V, right? Yeah, okay. So that will be VW. Therefore, if we will find from this one, VW is VT minus V over VT, right? And then if you will split them, you'll have here VW over VT is equal to VT over VT, right? So that will be 1, then minus V over VT. Therefore, this one, we can find this one because they are in similar triangles. Okay, so our aim is to find the value of V over VT. And then this problem should be already done. So, if we will use, okay, if we will use here the similar triangles, look at this triangle, okay? So, this triangle, and then this, and then this triangle. We get a big triangle and then this small triangle. So that will become base to base. No, volume to height. Okay, volume to height. So V. So we have here volume. Okay, that's the volume of the top part, and then the V total. And then this should be equal to the height, right? To their heights. What is the height of V? Wait, this should have 1/3 here. Sorry about that. Should have 1/3. So the volume of this one is, the height of the V is 1/3 h, right? And then the height of the total volume of the tank is just h. So since volume is in cube, right? So this should be in cube also. So as you can see, this h will be cancelled out. So we will have V over Vt is equal to just 1/3, 1/3 over 3. Sorry, 1/3 of cube. So this is equal to 1 over 27, right? So we already have the value for this one. So using this formula, you'll have VW over VT is equal to 1 minus 1 over 27. So this is just 26 over 27. Therefore, this is the ratio of the volume of water to the volume of the tank. Again, we use a similar triangles or ratio and proportion. So let's move on to the last problem. Okay, so for our last problem, we have two capacities of two hemis hemispherical tanks are in the ratio of 64 and 125. 64 to 125. That's capacity. If 4.8 kilogram of paint is required to paint the outer surface of the smaller tank, then how many kilogram of paint should be needed to paint the outer surface of the large tank? Okay. So we get a hemispherical spherical tanks. It doesn't really matter what is the shape of that one. So because we will be dealing with the principle of we'll be using the principle of similar figures. So if you say capacity, that will be the volume. Therefore, we already have a given here, which is V1 over V2 is equal to 64 over 12. Okay, but we have here 4.8 kilogram of paint. Okay, so 4.8 kilogram of paint. That since this is a mass, let's just make this M1. Okay, so this will be the amount of paint that you needed to paint V1, or the first tank, or the smaller tank. Now, um, as you notice, what happens here is, and kilogram, this is in kilogram, right? And then the volume is in maybe centimeter or meter, whatever. So they're not in the same unit. Okay, so kilogram is not aligned with the centimeter, so you cannot use simply like m1 over m2 is equal to v1 over v2. Since v1 and v2 are in cube, then you should also cube. This is not like that because they are in not in, because if the other one is centimeter, and then the other one should be in centimeter too, so they are not equal, so you cannot do it directly like that. So what you want to do is you have to figure out that the mass or the paint required is, or the mass or the paint required is directly proportional to the surface area, right? The larger the surface area, you need more paint. Okay, so let's say sa. Therefore, using the proportionality constant, you can rewrite this as m is equal to k. I think we can just use s to make it simpler, right? Where's the eraser? There you go. Okay, ks. Okay. Therefore, um, what we can make a relationship with is v1 equal over v2. This is now surface area, so s1 over s2. This one we can do that, right? And then from this equation, you can have here s is equal to m over k, right? That's m over k. So what you want to do is, where's the mouse? There you go. So v1 over v2, this is equal to, so s1, s is equal to m over k. Therefore, I can rewrite s1 like m1 over k, or, and for the s2, that will be m2 over k. But we have to make it equal. So v1 volume is in cube, while the surface area is in squared. So what you want to do is just simply square this one and then cube this one, so it will be equal, right? Because originally the surface area is in squared, so squared times 3, so 2 times 3, that will be 6, while the volume is cube, so 3 times 2 is also 6. So you can simply cancel out k, and then you'll have your v1 over v2 squared is equal to m1 over m2 cube. Okay, we already have the value for v1 and v2. That is 64 over 125 squared is equal to m1 over m2. We have m1. m1 is 4.8 over m2. And this is in cube. Okay, all you have to do is just solve for m2. If you were able to solve for m2, the answer for that one is simply 7.5 kilogram. So this will be your answer. And that is the last problem. So that is pretty much it for the trigonometry. So I was able to cover a lot of topics of trigo, which is the topics covered by the board exam here in the Philippines. So I hope you guys learned something about this video. So if you have any questions or clarification on the questions from this video, just leave a comment down below. And of course, I really hope that someone okay, or some students will be able to watch the whole video, because this is quite a long video. I'm not really sure how long it is, but it may be more than 1 hour. I'm not really sure. I have to edit out first before I will be able to figure out how long will this be, how long this video will be. Again, I want to thank you all guys for watching, and I hope you guys are having a great day. And don't forget to like this video if I was able to help you in any way. and subscribe to my channels, and then clicking the notification bell so that you will be notified as soon as I upload a new one. So I'm planning to do every math subject as much as I can. So this is really good for students or reviewees preparation for your board exam. So again, thank you guys all for watching and have a nice one, and I'll see you on the next video. Bye bye.